So it has been quite a while since I last posted a video, because I've been quite busy on one of my projects which I'm working on. This is a prototype board which I've been working on for the last few months, but unfortunately as a prototype it had some issues, so I need to produce another one, and this is the second revision of the board I have. Since I haven't posted in so long, I thought I might as well just document the entire process of how these things are manufactured, if anyone happened to be interested in them, since I don't know how well you can see, but it's quite complicated. So the machine you see here is called a reflow oven. In particular, this one is an infrared reflow oven. So you can see that inside the light is going off, and that's basically what it uses to heat the board up to its temperatures. So what we're going to do is we're going to start by soldering this square onto the backside of this board at a higher temperature, so then when we go to apply the other components to the other side, we can use a lower temperature so that when you place this in the oven, the part on the back doesn't just fall off. So I've already started preparing this part. So aside from the soldering profile which you need to set up, depending on how much you're familiar with this basically is setting different temperature breakpoints that it will reach during the soldering process. And so that's already been set up. So all we have to do now, or it's already been done, is apply a bit of solder flux to the bottom of the board and place the component as close to perfect alignment as I can do by eye. So if you look at this, it's pretty much within the square. And thanks to the flux, it should be able to flow nicely and pull itself to the center when it's done. So if I can find the lock for this, there we go. If I can find the lock with one hand. That's the tray. The board goes in. Just need to make sure that it is still aligned, which it is. And now the process begins. Just need to probably wait a bit since it's been 140 degrees for a while. I need to get the actual board to heat up to that point as well, so I'll be back in a short while. Well, while that's heating up, I can also just show you what the board itself looks like. So this is the component we're soldering right now is called a BGA package because on the backside of the component it has a few hundred balls of solder, or little blobs of metal, which once they melt will basically fuse themselves to the pads on this PCB. This part is actually essentially a microcontroller. On the other side contains the supporting circuitry. This board itself is 4-layer, if anyone knows what that means, but it just means that these tiny traces of metal which you can see on the surface also pass through on the inner layers as well. So you can only see 2 layers from the outside, but there are 2 more on the inside that are hidden away. You can probably see them actually through the center. So if you look at the center, the darker parts are the inner layers, and they're darker because the light is taking or losing some energy going through. But yeah, once this side is done, we'll be populating, well actually, we'll be using this, it's called a stencil, to apply a metal paste effectively to these golden pads, and then on top of those pads we're going to place the components, and then we're going to put it back into the oven to cook it up. So it should be about ready now. It should have preheated enough, so I'm going to go ahead and start it. If I remember what the buttons were, it should just be so hopefully this will work first time, but sometimes it's a bit finicky. I might have to do it a couple more times, which is not ideal, but it's just how it is. But yeah, you can see that I had to solder a board connection because the first time I made this board I made a small oversight with one of the data pins, so it was not ideal. and one of these boards costs about $160 to manufacture. In total, with both these boards, it's like $350. So I have to convince my university to somehow pay for that. So we're approaching the first breakpoint. I'm just probably going to cut here, and we will come back once it's finished refilling. Okay, well, it should be done now, so I should just be able to pick a draw. Let's just hope that it actually soldered itself, which it has not. Okay, so we'll have to try this one more time. So if you look at up closely, you can see that there are a bunch of little metal balls on the bottom of this chip. If I can... Oops, that's not ideal. But yeah, these balls need to fuse with the pads, and they did not. And I have a suspicion it's because of the flux, so I will clean that flux and get rid of that. We'll try one more time. Okay, so I've cleaned those pads up again one more time. So I'll have to go back to try and placing. It's actually quite hard at one hand. Well, that looks about right. So we will close the drawer and try it again. Hopefully this time it decides to solder itself. If you noticed why the pads on this board seem to be a different color, the copper traces and then the pads themselves have to be coated in the material to protect the copper, since if you are aware, copper oxidizes quite easily and turns green, and that isn't something we want, otherwise it can affect the connections between the components. So on this board I used a cheaper surface finishing called Hasl or HASL. It basically is just a layer of tin solder on top of the copper to protect it, but because of that, while it's usually fine for most boards, with something with components this small, it's not ideal, especially for the BGA package, because it creates an uneven layer and can affect how the connections end up forming. So this second iteration has been made with a process called ENIG, which is basically a nickel and gold deposition on top of the copper pads. It's a very small amount of gold, but it's still gold nonetheless, so it's a bit more expensive. Well, it seems like it has finally decided to actually solder itself onto the board. So, thankfully it has worked. I just need to clean it up a bit, and then we need to get to applying the solder paste to the other side. Okay, so with that should be all of the passive and ICs soldered onto the, or rather placed onto the board to be soldered on in the refill oven. So I just need to make sure that everything is about right. The components are still a bit lopsided or offset a bit, but that's only because once you put it in the oven, and apply enough flux, the heat will melt the solder and the flux will ensure that all the connections stay separated. So the components being a bit out of place won't matter too much. Just turn everything on. So it's a lower temperature solder as well, so we need to change the protocol for that. Just checking to set up correctly, so it's 185 peak. That should be about right. Preheating is going to be set to 110. And that should be good. So, the purpose of this solder flux is to ensure that everything is clean as it heats up. And then once the solder is melted, the surface tension is going to pull all the components onto the pads as they should be. This is kind of hard to do with one hand. Okay, so with that, I should be able to get started, select. So I will get back once. Oh, you can see that the flux has already started melting, which is what we want to see. You can see how it's already started spreading out across all the components. So as long as everything is flooded in some flux, once the reflow temperature is reached, then the surface tension should pull all the parts together. Well, for the most part, the board has come out well enough. There are still some bridge solder connections on smaller IC packages, but those should be something I can do later. It's like almost 6 now, so I really should have left the lab like an hour ago, so I have to come back to this tomorrow. But for now, I got basically everything that I wanted done, so yeah, just need to leave everything behind, I guess, until tomorrow, and hope that nobody gets there before I do, otherwise I could have some problems. Anyway, that'll probably be it for this time. And I will see you later.